Hi, Chem 12. I got one question from the previous day's classwork. It was this one on page 148. It's a hydrated complex, is what that's called when you have the water attached to the metal. So this one's a little bit unique. You can run it through the chart. Br is not going to hydrolyze as it comes from HBr, or the other way to look at it is it's acting as a spectator ion because it isn't going to hydrolyze. Now you've got the metallic part all the way to the OH. If you look that up on your Ka table, that's actually found on the bases side, okay, not on the acid side. So because this is found on the base side, this salt is going to be basic. Okay, so that's kind of an odd one, a little bit difficult. So again, because the metallic portion is not on the acid side, but it's on the base side, that's why that one is going to become a base. So what I wanted to do today is look at the Ka calculations. Okay, so again, we used the ice tables before, so we'll be using them again here. There is a little bit of a difference that I'll get into. So let's look at the calculations. Okay, so first one here wants you to find the pH when you have 0.25 moles of acetic acid in a 1 liter solution. Okay, and their Ka is provided to you. If you have questions out of the textbook and the Ka, you need the Ka and it's not provided to you, just look in the back of the book. So there's our equilibrium. Okay, so weak acid ionizing to acetate and hydronium. So you do your ice table. Okay, so there's your ice table. You start with 0.25 of the acid. It's going to get reduced, and then you have none of the products to start off with. There's a 1-to-1 ratio, so they'll go up by x, which is an unknown, and leaving you x at the end. Now, if we were to put this in, we would end up with a quadratic if we kept this in as it's written there. Now, remember the difference between a strong acid and a weak acid. A strong acid is going to ionize completely. A weak acid is only going to partially ionize, and it's actually quite poor in terms of the level of ionization. So what your textbook does is it makes an approximation or an assumption, and the assumption is that since this is a weak acid, x in comparison to the 0.25 is going to be much, much smaller. So after, if you didn't know what x was and then you subtracted, it would still round out to 0.25. So this is where this is coming from. 0.25 minus x is approximately equal to 0.25. Again, it's because the ionization level is very poor. So now here's your Ka. It's equal to x squared because these are both x times x over the 0.25. Okay, not the 0.25 minus x. So again, if you were to have like that, that would set up a quadratic, which would be much more difficult. You solve for x, which gives you H plus. Remember, you need H plus to get the pH. So the pH is found from the negative log of the 0.0021, so that gives you 2.67. Okay, so the key part here, use the ice table, but also recognize this assumption. Okay, next one here. Now, this one's a little bit different. They've given you the pH already, and they want you to find the Ka. Okay, so here's carbonic acid. So again, we can start with the ice table. Now we can find the H plus from the pH. Okay, so remember the H plus is equal to the antilog of the negative pH. So that's going to be antilog of negative 3.49. okay, which is going to give you 0.00032. Okay, so that's how we get the h plus. So in this case now, because you're not working with x, you can put this into the ice table. So these two are going to go up by that amount. This is going to go down by that amount. So again, you can see you're talking about poor ionization. So essentially that is 0.24, right? So I just wanted to show you that it is pretty poor ionization. And then there's your product. So you can put that in your Ka expression, and that gives you 4.27 to the negative 7. Okay, the next one here is a little bit is a little bit harder. Okay, so here what you're looking at is NH3. So what you need to recognize is NH3 is a weak base. Okay, so that's a weak base. So it's going to have this type of equilibrium. So the same idea. You 0.1 is what you're starting with. These ones are going to go up by x, and this is going to go down by x. But again, we make the approximation that that'll round to 0.1. So now what you can do is solve. You need because you're talking about a base, a weak base. You're not going to go through Ka, but instead you need to find what the Kb is. Okay, so you find the Kb by using the relationship Ka times Kb equals Kw. So Kb is going to be Kw divided by Ka. The Ka that you're looking for is of its conjugate. So the conjugate of NH3, conjugate acid, would be NH4 plus. Okay, so we need to find the Ka, so we look that up. So it's 1 to the negative 14 divided by 5.6 to the negative 10. There's your Kb, and then that's going to equal to x squared, x times x, over 0.1. And then when you solve for x, just recognize that you're solving for OH minus, not H3O plus. So OH minus is going to be 0.00133. And so in order for us to get the pH, which is what the question is asking for, you need to first get the pOH. And you'll get the pOH directly from this. So take the log of 0.00133, that'll give you the pOH, and then you can solve for the pH, because remember, these two add up to 14. Okay. So these are important calculation questions that I want you to have a good understanding on. So what I'd like you to do is work on these questions at the top here, 152, 74 to 82. And again, just ask me if there's any of these you'd like me to go over for Wednesday's class. Okay. I'd asked you to do the acid-base quiz, number 1, a take-home quiz. I think most of you handed that in. If you haven't handed that in, make sure you get that in. I'd like to mark that this week. Okay, so I'll stop there. So again, make sure you get this done, and then send me any questions that you might have. Right? Again, look after yourself. Okay, bye now.